All right, so I've started off the solution a little bit. This is what was available in the project in the resources section for the last video, and then I've copied over the radix sort and the radix single sort methods from the implementation we worked on when we covered radix sort. I did not copy over the get digit method because we're sorting strings, so we're not going to need it. So let's think about the method that we're going to have to replace the get digit method with. What do we actually want to do? Well, we're going to want to get the letter in the position that we're looking at. So when we sort these strings, we're going to want to start at the right, just like we did with the integer values, because the least significant position is at the right. And so just like with decimal numbers, we want to go from right to left. So when we're sorting based on the last position in the string, we're going to want F, C, E, D, and B. So we need a method that's going to accept a position and figure out the letter that we're looking at. And this is actually easier to do than it was for decimal numbers. So let's add that first. And I'm going to call it getIndex because what we're basically looking for is we want the index into the counting array. That's what we want the method to return. So I'm going to say public static int getIndex. And this is going to accept the position that we're looking at and the string. So if we want to get F, C, E, etc., we're going to pass 4 as the index because this time we want the 0-based index, and we would pass the string value. And inside here, all we have to do is call the char@, method. So we can return value dot char@, position. So this would give us, for example, F, but that's not what we want because we want to return where F is being counted in the counting array. Now A will be at position 0 in the counting array, B will be at position 1, C will be at position 2, D will be at position 3, etc. So A is at position 0. So if we want to figure out where F is, we'll get F and then we're going to subtract A. And that will give us the position in the counting array. Remember, characters are actually numeric values under the covers. So if A has a numeric value of, I think it's 65 in ASCII, but I'm not absolutely sure about that. But if it's 65, in ASCII, the letters A to Z, lowercase, all have contiguous values. So A is, let's say, value 65, B is 66, C is 67, D is 68, etc. So if we want to get the position in the count array, we need to translate these letters into the indices 0 to 25. And so A would be 65, minus 65 is 0. So it's at position 0 in the counting array. B would be 66, minus 65, which is 1. So it's at position 1 in the counting array. C would be 67 minus 65, which would be position 2 in the counting array, etc. And so what we're doing with this is we're translating the numeric value for the character into an index in the counting array. And because the letters A to Z in the ASCII system have value 65, 66, 67, and we keep increasing by 1 all the way to Z, we can translate a character to its position in the counting array just by subtracting A from the value, whatever the value for that character. And so that's what we're doing here. And so this is going to return us the index in the counting array. Okay, a brief time out here. After I finished recording this video, I looked up lowercase a in the ASCII table, and it turns out that lowercase a has a value of 97. It's uppercase a that has a value of 65, so I suppose I was half right. But the discussion still stands because the lowercase a is at 97, the lowercase b is at 98, the lowercase c is at 99, etc., all the way up to z. We can translate the numeric value for a lowercase character to its index in the counting array by subtracting out the character a. But I thought I'd record this brief timeout in case anybody noticed that I was actually using the ASCII code for an uppercase A when I was discussing how we were doing the translation. So that's it. Now we'll return to our regularly scheduled video. And so because of that, we can come in here and we can change the get digit to get index. And we want to pass the position and the value, and that's all we need. We don't need the radix. And we'll fix this error later. Right now we're thinking that the value is an integer. So that's all we need here for this get index. And the same for this one. So we'll change this to get index, and we can just remove, once again, the radix. And we'll fix the other errors later. So now that we have our get index, and that was probably the most difficult part of modifying the radix sort so that we can sort strings, let's fix the rest of the code. So first let's call our radix sort. So when we do that, we're going to be passing a string array. So we'll modify that. So we'll say string. We're still going to want to take the radix and the width. Now in here, we actually want to modify the loop because the position we pass, we want to start at the rightmost position. It was okay for us to start I at 0 and increment when we were dealing with decimal numbers because the get digit method was coded in such a way that when I was 0, we were actually raising 10 to the power of 0. And so we were getting and the calculation we were doing was giving us the rightmost digit. But now that we're just using value.char at position, we actually want to count I down from the length of the string down to 0. And so we want to count I, we want to start I at width minus 1. We're going to keep going as long as I is greater than or equal to 0, and we're going to decrement I. And so this time we really do want I, because of the way the get index method is coded, we really want I to start at 4 and then go down to 0. And then, so that's all we have to change here. For the radix single sort, we're now going to be accepting a string array. So we'll change that to string. And because of that, we have some fixes we need to do here. We're going to have a string value. And down here, our temp, we're going to have a string value for the loop. And then down here, our temp array is actually going to be a string array. And that's it. That's all we have to change. So as I said, probably the most difficult part was figuring this out. So let's run. And we're not going to see anything sorted because we need to actually call radix sort. So let's do that. So radix sort, we're going to pass our strings array. This time we have a radix of 26 because there are 26 letters in the alphabet, and our width is 5 because each of our strings has 5 letters in it. So now let's run. And we have sorted our strings, A, B, C, D, E, B, 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 C, D, E, F, D, B, A, Q, C, and O, M, A, D, D. And so as I said, probably the most challenging part of this was figuring out how to get that index, and maybe you didn't find it too challenging. And then of course we needed to modify this loop because we now want to start I at the rightmost position because of the way we coded this method. And the rest was basically just a matter of fixing up the call to get digit, changing it to a call to get index, and fixing up areas where we used int when we actually needed a string now. So as you can see from these challenges, once you know an implementation of a sort algorithm, it's not really all that difficult to modify it to sort different types of data or to sort in descending order rather than ascending order. So the most important thing is that you understand the steps that an algorithm takes to sort a set of values, because once you know the steps involved with the sort algorithm, you can then code the implementation that you need to do what you want to accomplish. All right, so that's it for sort algorithms for now. In the next section, we're going to start looking at lists. I'll see you there.